This is a vector. All vectors have a magnitude and direction. The magnitude is the length, and direction is the angle. Let's take a look at this vector. This vector has a magnitude of 2 and an angle of 45 degrees. While this vector has a length of 3 and an angle of 135 degrees. While this vector has a length of 3 and a magnitude of 40 degrees. Vectors can also be represented through its components. Let's take a look at vector v. It can be represented through I and j. I is the horizontal component and j is the vertical component. Now let's see how we can interchange between the two parts. Let's take a look at this vector with magnitude q and direction theta. You can find the components using a simple trick. Just use q cosine theta and q sine theta, and those are the components. Cosine for horizontal and sine for vertical. Also, if they give you components a and b, let's say here, you can use the Pythagorean theorem to find the magnitude, because all vectors form a right triangle. And if you wanted to find the direction, you could just use tangent. The tangent of theta is equal to b over a, opposite over adjacent. And you can isolate theta by using the arctan, and that's how you get direction. Here's an example. Vector v has components 5 and 12. Keep in mind what you need to find if they give you components. They probably want you to find magnitude or direction, and it's vice versa. So let's start by using the components and graphing it. So they give us 5 and 12. We go over 5 and up 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And as you can see, a vector is forming. And this makes a right triangle. We can use the Pythagorean theorem to find the length. So 5 squared plus 12 squared is equal to c squared, which is the length. And so that's 25 plus 144 is equal to c squared. Oops, I messed up. I wrote 169 instead of 144. So 25 plus 144 is equal to c squared. 169 is equal to c squared. Root 169 is equal to c. So c is equal to 13. So the length is 13. And so we need to find direction now. To do that, we could use the arctan. So let's set up an equation. Tangent theta is equal to 12 over 5. Remember, tangent is opposite over adjacent. And we could isolate theta. So tangent of -1, 12 over 5 is equal to theta. And if you just plug that into your calculator, you will get theta is equal to 67.38 degrees. And that's the direction. Here's another thing to keep in mind. Vectors can be added together or subtracted. But we're only focusing on addition today. To add vectors, you have to put a vector's terminal point at another vector's initial point. You can't have two terminal points together, and you can't have two initial points together. That wouldn't work out. Let's try an example now. Here's the first example. So I toss a baseball straight at 90 miles per hour with respect to gravity. And the wind is blowing up at 30 miles per hour. Now I have to find the new resulting force on the baseball and a new path. So you can add the vectors together, making a right triangle. So that's the baseball vector, and I also drew the wind vector, 90 and 30. This makes a new vector, and you have the components. So now you can find the direction and magnitude. Let's start by using the Pythagorean theorem. 30 squared plus 90 squared is equal to c squared. So that's 900 plus 8,100 is equal to c squared. Root 9,000 is equal to c. And if you plug that into your calculator, you should get, let's see here, 94.868. And that's your new magnitude. And we need to find direction now. So we can just use the arctan. Let's set it up. The tangent theta is equal to opposite over adjacent, 30 over 90. And you have to isolate theta. So you get tangent of -1 is equal to 1/3. I simplified. And you plug that into your calculator, you should get 18.43 degrees. And that's the direction and magnitude. That's example 1. Let's try another example. So there's a box with respect to friction, and there are 3 people pushing on the box at different angles. They are represented by 3 vectors, and I'm just drawing them out right now. Normally these physics problems, they want you to find the new resulting force and direction of the block. You can add all the vectors together to, oh, I shouldn't write that, I already told you. So I'm adding the vectors right now. 8, 20, 10, 75, and 5, 300. So what you have to do is you have to find all the components of each vectors, and after you do that, you can add them together. So I'm just getting the components of the first vector right now, using cosine and sine, and I'm finding the components of the second vector. Make sure your calculator is on degrees mode when you're doing this, or else you're going to get a different answer. So I have found all the components, and I just plug them into my calculator, and you should get a new component of the new vector, which is 12.6 and 8.065. So that's the new component of the resulting vector. Now we can write that down so we don't forget. And let's just draw it out. 12.6 and 8.065. It forms a right triangle, and you can make a new vector, and doing what we did before, we can find the magnitude using arctan. So tangent theta is equal to 8.065 over 12.6. Isolate theta as always. You get tangent negative 1 is equal to 8. No, my bad. Tangent negative 1 is 8.065 over 12.6. Now, plug that into your calculator and you should get a degrees. 32.6, that's what you should get. So that's a new direction. And we can find the length or the resulting force using Pythagorean theorem. 8.065 squared plus 12.6 squared is equal to c squared. And plug that into your calculator, you should get 65.044 plus 158.76 is equal to c squared. Add them together and square root it. You should get 223.804 is equal to c. And so c is equal to 19.96. 14.96. And that's the new resulting force, 14.96 pounds at an angle of 32.6. And we are done with vectors. I'm just writing down the answer right now.